The sum of root is going to be equal to p squared plus q squared, and the problem is we are going to make the sum of root and the product of root in terms of p plus q and pq. So is there any way to do this? Let's do some math for fun. Today we are going to do some practice about forming a quadratic equation with given roots or with given form of following roots. And then some question are like very easy, but not this time. This time is like incredibly hard because we got this some savage form of roots. And here is the question. A quadratic equation which is 2x squared minus 6x plus 3 has two roots p and q, and your job is to form a quadratic equation with following roots. Question number 1, p squared and q squared. Question number 2, p cubed and q cubed. And question number C, p power of 5 plus p power of 4 times q, and p power of p times q power of 4 plus q with power of 5. And as always, if you guys interested in this question, pause the video and try them for yourself. I hope you guys solve the question, and now here's how we're going to solve. Now, before we are going to solve for question A, B, and C, first thing when we're talking about to form an equation with following roots, we must identify the sum and the product of roots, right? So, in order to do that, I have to convert this into its general form. So, 2x squared minus 6x plus 3 equal to 0. And then we can find the sum of roots. So from this equation, from this quadratic equation, the sum of roots is going to be p plus q is equal to 6 divided by 2, which is equal to 3, right? And then the product of roots, oh no, okay, sorry guys, sorry. So this is minus. So we got p plus q is equal to 3, so it's still the same. But the product of roots is going to be equal to negative 3 over 2, which is equal to pq. Now, since we already find the sum and the product of roots, now we can apply this to this question ABC in order to find the quadratic equation with the given roots. So now here's how we do. So for question A, it is kind of easy because it is always appeared in the book. So p squared and q squared. So for question A, so the sum of root is going to be equal to p squared plus q squared, and the problem is we are going to make the sum of root and the product of root in terms of p plus q and pq. So is there any way to do this? Yes, we have a way. That is, we know that p squared plus q squared is the sum of the p and q bracket square. But can we use p plus q bracket square? Since p plus q bracket square is same as p squared plus 2pq plus p plus q squared, and then we got the term p squared and q squared, and then if we take the 2pq to the other side, we will get its minus version, right? So what I can say is p squared plus q squared is same as p plus q bracket square minus 2pq. And then here's the thing, I can plug in the pq to here and then p plus q to here. So p plus q to here and then pq to here. So which is equal to 3 square minus 2 times 3 over negative 3 over 2. So it is equal to 9 plus 3, which is equal to 12. So the sum of roots is equal to 12. And then let's figure out the product of roots. So the product of roots is equal to p square times q square. And by using the law of indices, we can get the square out of the pq. So it is equal to p times q bracket square, and then we plug in the product of root to here. I will get negative 3 over 2 bracket square, which is equal to 9 over 4. And then what we can do is, since we already figured out the sum of roots and the product of roots, we can finally form the equation. So our equation form, quadratic equation form, is x squared minus 12x plus 9 over 4, which is equal to 0. And then I don't like the constant or the coefficient of x squared and x to be a fraction. So I'm just going to multiply 4 at both sides. So I will have 4x squared minus 48x plus 9 equal to 0. And this is our answer for question A. Now let's solve question B, which is a slightly harder. So our question B, the roots is p cube and q cube. So the sum of root is going to equal to p cube plus q cube. But here's the problem. P cube plus q cube, can we do anything? Yes, we can. But wait. Now, since this situation is this situation, what if we have in terms of p plus q bracket cube? But what is the value of p plus q bracket cube? So now here's the thing. Now when you have p plus q bracket square is equal to p square plus 2pq plus q square, right? So if we have p plus q bracket cube, which is equal to p plus q times p square plus 2pq plus q square, I believe it is going to be equal to p cube plus 3p square q plus 3pq square plus q cube. So okay, this is correctly. So this plus q cube. So p cube plus 3p square q plus 3pq square plus q cube. Yeah, you have to see his q cube. Okay, and then what we're going to do is since we are going to search for p cube plus q cube, so we will have the term 3 times p square q plus 3 times pq square move to the other side. So p cube plus q cube is going to equal to p plus q bracket cube minus 3p square q minus 3pq square. And here is our problem. We got negative. So what can I do? So now the 3 and the 3 we can factorize. So p plus q bracket q minus 3, negative 3 and negative 3 we can factorize out. And we got the term p and then q, and we got the term p and then q. Why don't just factorize down? So we got pq. So our remaining term for this is going to be p plus the remaining term for this is q. This tells us what? This tells us that we have actually interpret this term to this in form of p plus q and then pq. So So we can finally plug the p plus q and the pq to here, right? So which is equal to 3 minus 3 times negative 3 over 2 times 3. So our answer is 27 plus 3, so 3q, so 27 over 2, which is equal to, we got multiply over there, I will have 54, so 54 plus 27 will be 81 over 2. So this is the value of the sum of roots of p cubed plus q cubed. And then we're just going to find the product of root. So product of root is going to be the same, it's going to be very easy. So the product of root is p cubed q cubed, which is equal to p times q bracket cube, which is equal to the cube of the negative 3 over 2. So we got negative 3 over 2 cube, which is equal to negative 27 over 8. And then since we already figured out the sum of roots and the product of roots, we can draw the conclusion that x squared, that our quadratic equation form is going to be x squared minus 81 over 2 x minus 27 over 8, which is equal to 0. And then multiply 8, because if we just multiply 2, we still got the fraction right here, so we just multiply by 8. I will get 8x squared minus 4 times 81, so that's 324, I think. So 324 minus, don't forget x, minus 27, it is going to be equal to 0, and we got the solution for the roots p cubed and q cubed. As you guys know on the title, that this is just the part 1 of the video. Yes, because in part 2 I will only discuss about question C, because I know that, because I expected that question C will take a lot of time to do the question. And as always, if you guys enjoyed this video, leave a like and subscribe to my channel for upcoming math videos, and I will see you guys next time.